Okay, now, people did pretty well on it, but most people didn't get it. Only two people got it completely, okay? Same two people that made A's on the test, okay? Uh, and then everybody else, almost everybody did something good. And most people were just one step away from putting it together, which means that when you did the homework, you learned something, okay? Now, you want to be able to push it a little further and really nail it. And if you didn't do well on the test, and I'm not prepared yet to tell you, but if you want to email me, I can email you back and let you know how you did. Okay. 2 weeks from yesterday, midterm's going to be due. It'll be in the testing center next week. It'll cover through what we cover this week. Okay. So let's see what more you would have needed to do this. There are several ways, several things you can estimate here. But the first thing you would probably want to estimate is the intercepts, because you know that the intercepts are always important. Okay, so estimate the intercepts. Now, I really like using vertical and horizontal dotted lines to indicate coordinates rather than cluttering up your x-axis. There's often a lot of stuff going on the x-axis that you don't want to clutter up with your labels. That's not required if you want to label your intercept here. And I'm going to say that's maybe x equals 5 on this line. Okay. So if you want to put 3.50 there, that's okay, but it could get in the way. There are other things you might want to label. And if you have x equals 3.5 in the mark there, I know that you know where the x-axis is, and then you're going to write it out someplace, okay? You're going to write the intercept, okay? And then this is x equals -2. Then the y-intercept y equals, oh, we'll just say 4. I think it's about 3.5, but we've already used 3.5. So we can say that's y equals 4. Yeah, 4 is good. Okay. So the intercepts are 3.50, -20. Now you might have made other estimates. You drew a different graph. You tried to draw the same graph I did. Your numbers might be different, but the process is going to be the same. Now, if you put the vertex on the y-axis, I would say you didn't do a good job of drawing the graph. Okay? You oversimplified it. And if you got everything right, but by means of oversimplifying, I might give you 7 points out of 10 instead of 10. Okay? Did everything else right, I'd just say I'm going to penalize you 3 points. The vertex is clearly not on the y-axis. Okay. Okay, anyhow, you got these 2 points. And the y-intercept is 0.4. Now, it turns out that's all you need. So one way of solving this thing is just to use this. Okay. This much is sufficient. I can solve the problem with nothing else. Okay. Now you have another alternative, which is to estimate the vertex. Say x equals 1. And I think y is about 4.3 right there. Okay. Now, maybe it's 4.5. You know, I don't care if you estimate y equals 5, that would be okay. It's not particularly accurate because this is clearly less than a unit. But half a unit would be perfectly reasonable, but you know, anything. As long as you estimate something a little more than 4, you estimate 3.5. Well, if you did everything else right, I'd still have to penalize you a couple of points for that. Because it's the vertex is clearly above the y-intercept. Okay? But, okay, another sufficient. Another sufficient set of estimates. Vertex 1, 4.3. And any other point. Okay. Now, why is this? Well, this is because using this form, you know that y should equal figure out what numbers to use here. Y could equal a times x minus b times x minus c. That's one perfectly good set of coordinates. The world is the cursor. Okay, there we go. Okay. Can you read that okay? It's pretty small. If we use the vertex, we get y equals a times x minus a squared plus a. Let me see if I can write this one a little more clearly. It would come out as clear as I'd like, and I'd like you to be able to see it. Y equals a times x minus b times x minus c. I don't really like using b and c here, but I'm going to use them anyhow because b and c could be like ax squared plus bx plus c, right? And b and c kind of invoke that. Matter of fact, bothers me so much, and I'm going to change it. I'm going to go all the way to the other end of the alphabet. X minus u times x minus v. Okay. Well, you see that if we have this information, this is all we need. Okay. Because u and v are the x-intercepts. You know, u, if x equals u, you're going to get 0. Well, 3.5 gives us 0, right? So you could let u equal 3.5. And -2 gives us 0. So we plug -2 in, we got to get 0. Well, that means that v had better be 2. Okay. And then we know that when x equals 0, y is 4. Okay. So we can quickly note that u and v are the x-intercepts. So that y equals a times x minus 3.5 times x minus -2. Then all we have to do is determine A. And we can easily do that by letting x equal 0, knowing that if x is 0, y is 4. So we plug in 0 for our x's, plug in 4 for our y. The only unknown we have left is A. Now you know that because you've used that, and about half of you used this formula in one way or another, put an A out there, or here. Okay? So this is one way you can do it. Now I'll complete it when I have a little more room. Another sufficient set of estimates, vertex is 1, 4, and any other point. Well, vertex is 1, 4.3. H and K are the coordinates of the vertex, right? So y equals A times x minus -1 squared plus 4.3. Any other point. If I know any point on this thing other than the vertex, I can solve it. I could take this point here. I could estimate the coordinates of this point and plug it in, and I would get an answer that I would totally accept. Okay, that's probably easier to use a y-intercept as a point, but it doesn't have to be. Okay, so for example, if I gave you the information that okay, the vertex is at 2, 8, and this graph contains the point 7, -14. You'd still be able to do this. You would have the vertex, you would have the coordinates, the x and y coordinate coordinates of a point, so you can solve for A. Okay? If you know the intercepts at any point, not just a y coordinate, just any point, if you know the intercepts, you can write this. Then if you have the coordinates at any point, any x, y, you plug in x, you plug in y, and you get A. Does that make sense? So that's how you use a graph to determine the equation of a function. Now, there are other things that you can do that kind of shortcut it. And if you know, there's some points that are easier to use than others. Like, it's always nice to use a y-intercept if you have this kind of information, because your x is going to be 0. It's going to make your equation just a little, for your numbers, just a little easier, okay? Okay, so to complete this, say, if y is of this form, use any point to find A. Y-intercept is a good choice. X equals 0, y equals 4. So 4 equals A times 0 minus 3.5 times 0 minus -2. Well, that means 4 equals A multiplied by -7. So A is -4/7. Actually, how easy that step is? So easy I didn't even explain the details because you can do those details. Okay. Well, this is just as easy. Once you have the form and only A to determine, you just pick any point. Okay, so if y equals A times x minus -1 squared plus 4.3, as I wrote before, use any point to find A. Okay, what point do you want to choose? Well, you can choose the y-intercept. Now, I wouldn't choose the y-intercept if I was trying to be pretty accurate here. Reason being that the y-intercept is so close to the vertex that you're going to have a more accurate result if you use a point further away from the vertex. Okay, it's just because things have to be so precise here that you're going to probably be off by quite a bit. If you use like 4.3 when it really should be 4.5, it's going to change your result by quite a bit. So just generally, because of that reason, you might not totally understand how the numbers make what I said. So use the point that you already have that's furthest from the vertex, or even estimate a point that's even further from the vertex. Okay, use a point that's pretty far from the vertex. You have to make a note of that. I'm not going to write it down, but it's a good policy. Well, this point's pretty far from the vertex, so I'm going to go ahead and use it. It's -2, 0. Use -2, 0, so we get 0 equals A times -2 minus -1 quantity squared plus 4.3. Okay, what -2 minus -1, this turns out to be -1, right? So 0 equals 1A plus 4.3. And you get A equals -4.3. I'm just starting to ask myself if I'm really happy with that, because I think if A is -4.3, things go a little more haywire than that. But I mean, your distance there is 3 units. -9. Something about that bothers me a whole lot. Okay, I did something really ignorant when I did this. H never mind, H is okay. No, it's not. Look, I said H was -1. Whole thing about the negative on H is messing things up. Okay. Okay, so again, what I got here doesn't make sense. If you look at the function and try to graph it, try to verify that you have the right function, it's not going to make any sense. It ought to be just 2 minus 1 here. And it ought to be just x minus 1, not x minus -1. Obviously, x minus 1 squared is going to shift your toolkit quadratic function 1 unit to the right. Okay. So I just was careless when I wrote down h equals -1. Because I just wasn't being careful. Okay, so now I'm going to get 9a plus 4.3. And that's going to give me a 4.3 over 9, which is negative 0.46, maybe 47. So again, made a little bonehead error here. It caused me to get something that didn't make sense. So I went back and found the error and corrected it. And I could emphasize there, I mean, that was a real error. I just didn't pretend to make that. But as I've always said, I don't try that hard not to make stupid errors because everybody does. And you got to see what happens when you do. Okay. It doesn't hold water when you get down here. And then you got to go find the error. Okay. So for this function, I didn't leave myself room to write it out very well. This out here, next right more. So I'm going to get y equals -4/7 of x times x minus 3.5 times x plus 2. Now again, to check this out, I can see immediately that my x-intercepts have to be -3.5 and 2. I could calculate my y-intercept just by multiplying this by this and then multiplying by -4/7. So I would get y equals 4. And that is the y-intercept. Okay. So we can check that that matches. In this one, now we can check that y equals, says so, y equals -0.46 times x minus 1 squared plus. Okay, many of you had this much. And you had the vertex, but you didn't use another point to determine what A was. Okay, so you were that close. I mean, you were really close to getting it. You just needed that one extra step. Okay. If you use this method, again, you had it. You just needed to use the coordinates, x, y coordinates of another point to evaluate A. Okay. Okay. Well, you guarantee that some way or another, you're going to have to graph at least one quadratic function in all its detail on the midterm. Okay, let's turn to polynomials. That polynomial? Well, you have an assignment that'll be due tomorrow. You got to do quite a few things with polynomial, okay? And that assignment is actually fairly extensive. Okay, so this polynomial, well, I'm just going to tell you because we've already talked about it, I think. What's the first thing you do when you do a graph? You look at the intercepts. Okay. So I'm just going to write this out. The x-intercept without a lot of explanation. Y equals 0. So you get 0 equals x minus 5 times x plus 4 times x minus 1. And then we'll just say, okay, well, yeah, but I'm going to put the 0 over here because that's where I want to see it. And then I'm going to say x minus 5 equals 0, or x plus 4 equals 0, or x minus 1 equals 0. Now, people don't often follow my advice to write the logic and to use the words that I use when I demonstrate these problems. You cut to the chase and you do what's necessary to get the right answer on the homework. I totally understand that. But if you write things out in the detail that I recommend, you're going to learn more and faster, and you're going to retain it better so that when you get on the exam, even though you're smart and you've learned everything as it goes, you haven't put it all together and you don't make a good grade. Okay? We try to avoid that. We all do sufficiently prepared. Should be making decent grades. Still haven't demonstrated that. Okay. Think you will on the midterm, but make sure you do. Okay, now. This is an equation to solve. This is an equation to solve. This is an equation to solve. I write 3 dots indicating there are some steps. It might be a more complicated equation than x minus 5 equals 4. It might be 17x plus 398 equals 0. Okay, but it's still easy to solve. Okay, it might even be a quadratic equation, which requires that you solve a quadratic. So whatever these equations are, you solve them. Here, though, it's easy. You get x equals 5, or x equals -4, or x equals 1. There's the zeros. Or at 5, 0, -4, 0, 1, 0. The y-intercept occurs when x equals 0. So y equals 0 minus 5 times 0 plus 4 times 0 minus 1, which is 20. So you do the end behavior. As x goes to plus infinity, with something like this. As 5 goes to negative infinity, right? And I write all this out. Now, I'm not going to write all that out in this example, but you probably ought to at least look back and read the boards and what I did in the MDE 61. See the kind of detail that I recommend you at least think through and preferably write down so you remember to do it and do it right. Okay? Because when a curveball comes at you, you want to have a structure for solving the problem in mind. Okay? So that you're more likely to solve it correctly. So you don't get lost in the details. So as x goes, this is not rigorously correct. So it's like if you multiply plus infinity by plus infinity by plus infinity, you get plus infinity cubed, but it's still plus infinity, okay? And infinity isn't a number, so you can't actually even do this, but I'm just kind of writing out schematically what goes on here. And later on in calculus, when we study limits more thoroughly, you'll better understand how this works. As x approaches negative infinity, y approaches negative infinity, equals negative infinity equals negative infinity. It's 3 negative, okay? Now we've got the intercepts and we've got the end behavior. Put x equals 5 out here. At x equals 1, so let's put x equals 1 here. The y-intercept is at 20. So the y-intercept is at 0, 20. So I've got a y-intercept, an x-intercept, an x-intercept, and an x-intercept. And this thing goes to plus infinity. Because we got 3 plus infinities. You do that, okay. And over here, so we got to come up from here, got to go through these points, and we got to end up here. And that's easy. So we just come up here, turn around, come down here, and come back up here, and there's our graph. One thing we want to be careful of is we don't go through the x-axis any place except at the zeros. Because the only way this product is going to give us 0 is if x is one of these 3 numbers. If x is one of these 3 numbers, 5, -4, or 1, then none of these numbers are going to be 0. And the y is not going to be 0. Okay? So we can't go through the x-axis except at the points where the thing can be 0. All right, now what if I change things? And let's say square this one and cube this one. Okay, what would happen? Well, I'm not going to do that on this board, but I'm going to do it. Okay, so we're going to use the same action. Y equals x minus 5 times x plus 4 times x minus 1. And I think, contrary to what I did before, I'm going to cube the x minus 4 and square the x minus 1. And so what's going to happen here? We're going to get the same x-intercept because whether we set x plus 4 equal to 0, x plus 4 cubed equal to 0, x has to be -4 to make it 0, right? So that should be pretty clear, but think about it. Same intercepts, x-intercepts, y-intercept x equals 0. So y equals 0 minus 5 times 0. Now, this, and you know that, but I think it's negative 320 because cube of 4 is 64 and 5 times 64, I think is pretty easy to find. It's negative 3, it's 320, and it's going to be negative. Okay. So we've got really almost the same picture, except it's different. What's different? Well, we're going to still have an intercept at x equals negative 4, an intercept at x equals 1, an x-intercept, and an x-intercept at x equals. So we're going to have to go through. So this is going to be negative 320 here. Obviously, our x and y scales are not the same. They don't have to be. Pretty much for most polynomials, they really can't be. If I wanted to use scale where x is 5 is this big, then I'd have to go down about 117 feet below the surface of the earth here to get my y-intercept. Can't do that. Okay, so I'm going to make the graph like this. Okay, now the other thing you got to be careful of is that, okay, if you wanted to graph y equals x minus 5, y equals x minus 5 isn't squared. Okay, I have okay. Y equals x minus 5, that's linear. Y equals x minus 5 would have a y-intercept of negative 5 and the slope of 1. Okay. But then it would be multiplied by this, which means the slope would be whatever you get when you plug 5 in for x there. So anyhow, it's going to go through x equals 5 in a straight line. Okay. So we pass through this intercept along a straight line. Okay, what about x plus 4 cubed? That means we take y equals x cubed and shift it 4 units to the left. Okay. Whether we're multiplying that by a positive or negative number. That depends on what this and this is. So you don't have to worry too much about that, but you know that this is going to go through here like x cubed because that's what this factor is going to give us, okay? It's just the x cubed function shifted 4 units to the left and then multiplied by whatever this times this gives us. So I'll write out just a little bit more. say like a multiple of x cubed. Could be a positive multiple or a negative multiple. It could look like this. Or like this. All right. Here, x equals 1. Well, that comes from x minus 1 squared. So it's going to be like a shifted squaring. It's going to give you a parabola at this point, or near this point, very near this point. Okay, so it's like a parabola. It'd be like a multiple of x squared at this point. Now, as x goes to infinity, every factor goes to infinity. In other words, x minus 5, if x is really big, is going to be positive, right? If x is really big, x plus 4 is going to be really big positive. If x is big, big positive numbers. This one, 3 of these, 2 of these. It's going to give you an unimaginably huge positive. Positive number is going to be so big that it's going to, y is going to approach infinity really fast. So again, I'm going to do this. This goes to negative infinity. X minus 5 goes to negative infinity, right? And x plus 4 goes to negative infinity. So x plus 4 cubed goes to negative infinity. Why? Negative times a huge negative gives you a huge, really huge negative number, right? It's the way signs work. So we have to understand that, understand the logic of why this goes to negative infinity, so this goes to infinity. X minus 1 goes to negative infinity. So x minus 1 squared goes to positive infinity. Because you're squaring a huge negative number, you get a humongous positive number, right? So what do you have here? Well, you got a negative here, you got a negative here, and you got a positive here. So put this together. It's a good thing. I didn't mark this point here, but that's your y-intercept. I should have marked it when I talked. Okay, so My behavior here is this. Now can I draw the graph? Well, I could draw a graph down here, through here, up here, through here, and somehow wiggle around and go like this. That wouldn't be the right graph. Okay, because it's got to be a straight line here. It's got to be like a squaring function here. That'd be parabolic. It's got to be like a cubic function here. So that's not right. So we just kind of cross that out, and we never did it. Goes through all the points. It only goes through the x-axis only at x-intercepts, but it isn't the right graph. Okay. Well, the graph has to come down here, and it has to act like a multiple of x cubed near this point, which means it's going to come down like this, and it's going to level off. Somewhere here, and then comes back up through here. Now what's it going to the multiple of x squared, because remember, this is x equals 1, came from x minus 1 squared, which is a shifted x squared function. So it's going to come up here and turn around. And I kind of missed the point. But then it's going to come down here, and then it's going to come back up. So now it goes through here like a cubic function, touches this point like a squaring function at its vertex, and goes straight through here. It's not really straight, it's curving here, but if you look at it really close to this point, just like if you look at the Earth from where we stand, it looks flat. Okay, this looks like a straight line if we zoom in real close. That makes sense? That's how you graph one of these things. And there are several things to remember, but all I have to do is practice. All I have to do is reason it out without looking at every step of an example. By the time you get to a few of these, you shouldn't be looking back at examples. Okay? And if you have to keep looking back at examples to get it right, you should then go to the practice, to go back and do it for practice and not look at it. Okay? That's how you learn to do it. Now, another quick example. Y equals x minus 3 times x squared plus x plus 6. Y-intercept very quickly, just plug in 0 for your x's. So you can already start graphing this thing. Okay, so x-intercepts. Well, if we follow the logic, how we write this out, we set the equation equal to 0 because y is 0. And this gives us x minus 3 equals 0, or x squared plus x plus 6 equals 0. Well, solve this, we get x equals 3, or x equals -1 plus or minus the square root of 1 squared minus 4 times 1 times 6. over 2 times 1, which equals -1 plus or minus the square root of -23 over 2. Now that's quadratic. We use a quadratic formula to figure out when it's equal to 0. It's real easy. Just got to remember the quadratic formula. And then do the arithmetic correctly, and I think I did it correctly. The point is we get a negative under the radical. That means you don't get a 0. You don't get an x-intercept. That you do get a 0, but it's complex. So there's no x-intercept from the factor x squared plus x plus 6, meaning your only x-intercept is at x equals 3. You look at the long run behavior. Well, for the end behavior, it's like this, like this. Okay. So as best you can tell, the graph comes up from here, very steep. Then it's got to get less steep here. Then it turns out it gets more steep. And that's about what it might look like. Okay. That's about all you can do. Now there turns out to be more of a unique calculus to do. Turns out that this thing could also make it wiggle. It could actually, it did that though. It could actually go from here and here, up here, and down here. It could come up here like this. It could have a little wiggle in it here. So it could have a shape much like, well, when I drew over there, you know, front axis. And actually, the wiggles will be above the x-axis in this for reasons that I don't have time to mention because they've only got seconds of that. Okay. Okay, so please do the best job you can. Get at least half of the next assignment done, and I'll extend it for you. If you don't get it done, you're going to have to go half credit to do it. You're going to be behind. Try not to be behind. Okay. Then next time we'll do the long division. Then next week we'll do a little review, especially Tuesday. The midterm, and I'll also hopefully have you copy the midterm type problems by the weekend. Hopefully by next month. So, kind of got them drafted, so we'll see.